vote button right here. And now you just jump to a 6% chance. So if you submit questions earlier in the stream, you have a better chance of getting picked right away. And then if you upvote more, also more. Okay, let's go choose the winner for the first question that we're going to be doing today. Here it goes. Spin, 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 spin. Let's go gambling, and it is going to be Gamer Jam. Okay, nice. All right, that's going to be the first question we go through. And look, Tomboy, you've now jumped to an 11.7% chance, so it goes up. I hope that makes sense. Love this. Here we go. This is a vectors question we're doing. All right. 2 boats, the Luna and the Tuna. Dude, what? Who calls their boats the Luna and the Tuna? Leave from the same dock at the same time. The Luna travels northwest at 8 kilometers an hour for 1 hour, and then stops. Oh, it's not vectors, it's trig. Yeah, but I mean, like, a lot of trig is vectors, basically. We can solve it with just trig. And then turns north and continues traveling. Oh, and then just stops. The Tuna travels northeast at 8 for 1 hour, and then turns north and continues traveling for 90 minutes at 8 kilometers an hour before stopping. To the nearest kilometer, what is the distance between the 2 boats? Cool. You can express this as vectors. Yeah, because watch. This is kind of the key thing we're going to talk about. And this is a physics thing. Distance, right, is equal to speed times time. Yeah. So let's look at the Luna first. So the Luna. So let's go Luna, right? Luna goes at 8 kilometers per hour times the time, which is like 1 hour. Notice how hours cancels. And that gives me 8 kilometers. And then they said that's northwest. I'm going to assume that's perfectly northwest. Which, again, if this is north, east, south, west, we learned to memorize this as, like, never eat soggy waffles. Exactly. Magnitude and direction, yeah. I agree. Let's make the Luna blue. Because, I don't know. Luna, to me, I think of, like, the moon. And the moon is blue, maybe? I don't know. I guess it should be yellow, but whatever. All right, so this is going to go up at directly 45-degree angle, and that's going to be at 8. That's going to have a distance of 8. And then here we can, like, mark some angles here. And then this is 45 degrees. Okay. And then the Luna stops. The Tuna, let's make the Tuna red. Tuna's kind of red, right? Or at least the inside of Tuna is red. The Tuna travels, again, same 8 kilometers per hour for 1 hour. But that's northeast. So that's going to be this amount in this direction, right? And this is going to be 45 degrees. And that's also going to be 8 kilometers. But then it travels... It is a right angle, exactly.
Good job.
No, north is true north. Yeah. Yeah. So I think the next part of its journey, which let's put that in pink. So 90 minutes at 8 kilometers an hour. 90 minutes is an hour and a half. You gotta make sure you convert that to hours, right? And 8 times 1.5 is gonna be equal to 12. And that's directly north. Yeah. That's not in the same direction it was already going. That's true north. So that's going to be 12 this way. And then it stops. And then they want to know to the nearest kilometer what's the distance between these two. So they want to know this. It's like the question. Draw an extra line. You see 2 right angles? Yeah. So, yeah, it is kind of cool here. We could, draw an auxiliary line. I hate the auxiliary lines, but sure. Yeah. So here's a cool thing we can do. We can draw a line connecting these two, for instance. I know. Yeah, I love drawing extra lines, dude. I really do. Yeah, okay, if we're not using vectors, if you want to just use, like, pure trig on this one, this is how we would do this. Which is trig, right? Triangles. Yeah. So, one way would be to convert these into components. Like, I could figure out, oh, how much has it gone this way? How much has it gone this way from that one? And then how much has gone this way? And that would give me the total.
Nice.
Left, right, up, down, it's gone. And I could get, like, a point. And once I have a point here and a point here, you can just find the distance between 2 points. But let's do it using just triangles. I'm cool with that. One second, let me get my chat working. I forgot to turn on this one. Let's turn this on. There we go. Okay. All right. Sorry, what's up, Crazy Run? I don't know why it keeps putting subscriber on channel. I'll fix that later. Okay. What's up, Eduardo? So, because this is 45 degrees and this is 45 degrees, I know this is now 90 degrees. Okay, so that means this is a right triangle. And even more so, we know that this distance and this distance is the same. So that makes it an isosceles triangle. Which, if this is 90 and these are the same length, that tells me that this angle right here is also 45 degrees. And then this angle is also 45 degrees. And so this triangle as a whole is what we call a 45, 45, 90, right? And what you should know, right, is that from a 45, 45, 90, right, so when you have a triangle that looks like this becomes 1, 1, square root of 2. Did we know this, Drew Taylor, for triangles? If it's a 45, 45, 90? So if this is 8 and this is 8, then this distance right here is going to be 8 root 2. They do. Yes. Okay. And now if this is 8 root 2, right? And we're trying to find the distance from here to here. Look what we got. I have another right triangle. Okay. And so now I can figure out this missing side of the right triangle by using the Pythagorean theorem. So that's just a squared plus b squared equals c squared. So I'm going to say 8 root 2 squared plus 12 squared is going to be equal to c squared. Wait, I put the wrong color, sorry. They got really lazy. How'd they get really lazy? Can we assume the 12 and 8 root 2 triangles to be right? Yes. The reason for that is we know that the distance that this thing goes up in the y direction is the same distance that this goes up in the y direction. Right? So the line connecting these 2 points, the horizontal line, is exactly perpendicular with a vertical line, which is just going north. What's up, Kilobyte? Yeah, that's how we know this is a 90-degree angle. It's because this point and this point have the same y coordinate, technically. Because they go the same distance at the same angle in the y component. Oh, 3-angle triangle? Oh, I thought that actually is quite... Yeah, why don't we call a square a quadrangle?
Oh, yeah.
Why is it a quadrilateral? Okay, so now we solve this. So now, solve. It's flat earther behavior? Why? It works. Okay. So, 8 root 2 squared is 64 times 2, so that's 128. Plus... Oh, yeah? I like E&M, actually. If you want to submit a E&M question, we might go over it. Just add it to the queue. There's a website there, Snazzy, if you haven't seen it before. All right, this equals C squared. So what's 128 plus 144? Is that 272? I think that is. Yeah, okay, so 272 equals C squared. Okay, so C is equal to the square root of 272, which, you know, if you wanted to get a nice number for that, it's not terrible. Use a calculator. Alright, so let's go figure out what the square root of 272 is. Oh, breasticles. Why did I say bad word? Sorry, let me give you perms. You can say whatever, dude. My bad. You said ass? Oh, yeah. Well, there you go. You can say ass now. Okay. It's 16 times 17? Oh, so it's 4 root 17? Is that the same thing? AP Physics C, yeah. Oh, it is 4 root 17. Yeah, that is actually kind of cool. Okay, cool. So it's actually equal to 4 root 17, or you could say 16 or approximately 16.49 kilometers. There we go. Cool. All right. There you go. Gamer Jam. Drew Taylor. That's how you would do that with trig. Nearest single decimal? Oh, to the nearest kilometer? Oh, okay, so 16 kilometers. Technically the nearest. Yeah. Yeah, all good. Okay, cool. All right. Great question. We're going to put that in our queue. All right. All right. Oh, did I not save this one yet? So let me save it. Nice. All right. Point for you, Drew. Actually, yeah, wait. Gamer Jam, right? Is that your name? Yeah, okay, cool. Interesting, square root of 16 times 17 is less than 16.5 by the AM-GM inequality. Oh, okay. Well, because square root of 16 times 16 would have been just perfect 16, yeah. All right, let's see what's next on the queue of questions to go through. Oh, we already spammed this one. We already spammed. Okay, here we go. All right. Let's go choose another winner. Let's go gambling. And it's breasticles. You're gonna give me another scary one here. Yes, come up and speak.
This one's not too bad, I don't think.
Oh, bless you. Bless you, bless you.
I think.
I see Fourier transforms. Alright, let's see.
It involves energy, so it's more
Okay.
physics than it is me.
It's more physics than math. Okay, here we go. Alright, suppose
Kind of.
x of t, y of t, and h of t are time signals following the three conditions. Finite energy. GG, man, what is this? Y of t is x of t times h of t, which is equal to x of u ht minus u du. Okay. And then the integral of absolute value of h of t is less than infinity. So it's finite, sure. Show that y of t has finite energy. Hint, use Fourier transforms. Raleigh's energy theorem and look back at the hint. See 7.3 might help. All right, let's
Yeah, and all this is in
the book.
is
Yeah.
in the
What page
book,
is this on?
Yeah.
What page is this on?
That would be C 7.10. Let me check here.
Lambda W function, and I thought I was a good troll. No, but these are at least solvable because they are from like an actual book.
Yeah, they're from an actual book. It's basically asking you
Where was it? 7.3 is where we were at. Where was it?
7.10. So if you control F and then C 7.10, it'll take you there.
Okay.
But it's basically asking you if those are like transmission, like time signals.
I see
like you'd
causality
in
and
engineering.
I see like Hilbert transforms. This is scaring me.
Yeah, keep scrolling down. It's on 278.
278. Okay, let's go see. Okay. Oh, there you go. Okay, here it is. Look back at the hint for C 7.3. Tensor calc, easy. Is this easy, dog? Okay. All right. This is a hint apparently. All right, we're gonna use this, I think. This says that okay, so the absolute value of an integral is always less than or equal to the integral of the absolute value. Okay. I guess that's cool.
Yeah. So
Because
I think basically what it's asking you to say is that
I mean, if we can prove that this, if we can show that if we can show this is finite, then we know this is finite, right? Because this has to be less than this.
Yeah, and then two finite values times each other would also be finite.
Yeah. What's up, Video Games Wizard? Yeah. Okay. Show that y of t is finite. Okay. So we have to show that x of t is finite. Well, okay, so x of t is already finite, so I don't fucking care, right?
Yeah, we already know x of t is finite.
Well, we know it has finite energy. What's Raleigh's energy theorem?
Well, that was what I was hoping you'd know, because that's...
I have no clue. I've never seen that before in my life.
I'd imagine it's probably electrical engineering. I've heard the name.
I know who Raleigh is. I know
times
Raleigh's
in modern
scattering.
physics, but
Yeah, I don't know what the fuck Raleigh's energy theorem is. What's his energy theorem? Oh man. All right, let's go find it. We're gonna go find it. Raleigh. No.
it says Raleigh's energy theorem, also known as Raleigh's theorem, also known as Raleigh's energy theorem, states that the total energy of a signal is equal to the total energy of its Fourier transform, establishing a fundamental relationship in signal processing.
That's cool. Okay. Okay. Let me remember what a Fourier transform is. I think Fourier transforms are like...
It's your Laplace's transform, but it's a special case of it.
I think it's negative infinity to infinity, and then it's like e to the I omega something.
Oh yeah, let me make sure you get the right equation first. Like that. But yeah, it's a special case of your Laplace transform.
Yeah. There we go. You pull out sine. Yeah. I see. I know that's it's pulling out sine and cosine waves. There we go. This looks legit to me. Okay. Yeah. All right. F of W It's negative infinity to infinity, and then, right, it's little f of t, e to the I omega t. Oh, it's not dw, it's dt. And then there's like a reverse transform. Okay,
Yeah.
cool.
But I don't think we even need the reverse transform because since we're using Raleigh's theorem, we know that the energy
As long as this is
equal to
finite.
the energy of the Fourier transform, yeah.
Is the energy of the Fourier transform just equal to this? What is the energy of the Fourier transform?
I think when it says the energy of the Fourier transform, I think it just means of.
Oh,
like,
here's what
applying
it
the
says.
Fourier transform.
Yes. I see. This is apparently the energy of a Fourier transform. Is equal to the integral from negative infinity to infinity of f omega squared d omega. That's what that's
Okay, I
equal to.
see. So and we know f omega, so we'd basically just square that integral.
Yeah, you basically just square the integral, and then you integrate again. I think that's what it says. The total energy in the time domain equals the total energy in the frequency domain. Yeah.
But I guess that kind of makes sense. That makes sense.
There's, yeah. Y is a convolution of x and h, so the Fourier transform of y is the Fourier transform of x and h multiplied by each other.
Yeah. Okay. That does make sense. That does make sense.
Okay. And then, I guess... Lonely me, why do you keep submitting so many things, dude? Here, Lonely, I think this is the thing you're looking for, dog. There you go. Okay. It's okay, Lonely. Is a convolution of x and h, so the Fourier transform of y is the Fourier transforms of x and h multiplied by each other. Okay. Why is it t minus u though? That's what's curious.
That's how a convolution works.
Okay. Oh, like there's a
it's
shift?
basically composing. Kind of. It's similar to how like Dirac delta functions can be used as
pick out
as
like
a
exactly where they're on
convolution.
top of each other.
And so like in the Dirac delta function that u is where it actually is.
I see. It's
similar
smeared.
concept.
Oh, okay. I also like this explanation of like this one like goes left to right, this one goes like right to left. Yes. Oh, I see. Okay. So multiplying them is.
Yeah. And it's the same idea that you use when you like if you talk about like Green's function, solving like a PDE or an ODE with the Green's function. It's a convolution to solve that.
Okay. So that tells me that I don't know. Y omega is equal to, what is this, negative infinity to infinity x of t e I omega t dt times negative infinity to infinity h of t. Yeah, okay. E omega t dt, sure. And then we already know that this integral, I guess, is finite. And okay, this is also finite, right? This must be finite then. If it has finite energy, yeah. And then when they say absolute value squared here, do I do the complex conjugate for this? I'm trying to think how this works. Usually like, yeah, if I have like absolute value, for instance, I don't know, like this, This is the same thing as like sigma is like psi star. So I think if I want to talk about
Well, I don't.
the energy
I don't
being
think we even need to use the complex conjugate, because if we know that if we scroll, we know that the f of omega is going to be finite, because we know that f of t is finite, and so the energy of the Fourier transform is equal to the energy of the function. But we know the energy of the function is finite.
And then,
Right.
well,
So
I think what I'm trying to get is because they tell me that, for instance, this integral is finite, but that doesn't have any e to the I omega t stuff. But I think because the energy is equal to this, which is the same thing as the conjugate times itself, and then, right, f omega is this one. Thanks, Rudo. Then this one, for instance, would be like, I don't know, like little f of t, e to the I omega t dt, and then this, or so that's negative I omega t, right? And then this is times f of t e to the positive I omega t dt. And then that's why these cancel out. And you end up getting just this. I guess, I don't know if there's an absolute value on it, but maybe, whatever. Yeah. Okay, but if
I don't think
it's,
it matters as long as we prove that it's finite.
right, okay. Yeah. So, okay, so I already know this is finite. Finite, cool. And then I think if I write this out, if I say like energy for that is equal to this, so energy of like h of t is going to be equal to integral of h of t squared dt. But then we were already told that the absolute value of h of t is finite, right? Are you use a different variable for the second integration? Which one? Oh, I see what they're saying. Maybe for... I see. Okay, whatever. You want to call this like... let's call this J. That better? I think that's better.
I do like alpha or something.
Alpha? Okay, let's
Yeah,
do
it gets
alpha.
weird because technically we're talking
J
about
is imaginary
like
and
signal
imaginary.
transmission,
Yeah, I got you.
and that's like
Yeah.
electrical.
You can't do that.
And they
Yeah,
use
can't.
J because I could be.
Yeah. I feel
Yeah.
it. Okay. All right. So the energy would be equal to that, but we know negative infinity to infinity of the absolute value of h of t dt is finite. So does that mean, I don't know, a finite thing squared is also finite, right?
Well, we could use I think I see. Does it give it? They tell us to use the hint from 7.3 that the absolute value
Which was this one?
of the integral is less than or equal to the absolute value
Of just the function.
The integrand squared.
Yeah.
So I figure we could use that to show that if we know that the value that's greater is finite, then the value that's less than also has to be finite.
Okay. I think that's I'm just curious where. Yeah, I understand. We know this is finite, but then where does this come into play? The absolute value of the whole function, or the whole integrand.
The way I think of it is, if you think of the integrand as the area under a curve, or the integral as the area under a curve from negative infinity to infinity. Like if we take a look at something like f of x just being f of x equals x, just a straight line, the absolute value of x when you take the area under that curve is always going to be greater than if you were to take the absolute value of
doing the integral, because you have negative parts that would have decreased the value.
That would have decreased it, but then you're making them positive.
Right. Okay.
So basically, like saying the negative area is still just area.
Negative areas, yeah. Well, so I understand that, but like, where does that come into here? where does I understand the logic behind this. Why is it a hint? Let's see. Okay. This is what chat kind of says. Dun, dun, dun. I think that property is what allows us to say that the square of it is less.
I think so, yeah.
Yeah. That's what I was getting at. Because I know that this is finite. I wanted to show that this was also finite. And so
yeah, let's see. I'm looking at the like the solutions for it. I can't find it anywhere online, but he says that Raleigh's theory, the energy of x of t is 1 over 2 pi integral negative infinity to infinity of the absolute value of x omega squared d omega. Yeah. Where he gets that definition of it from, I'm not 100% sure, but
well, I think that's a normalization concept, the 1 over 2 pi thing.
Yeah.
Yeah, okay. That's this. Yeah, which we did see earlier. Where was it? Where did I find that earlier? No. Where did I have it? Yeah. Oh, they didn't have this was like from Math Overflow. Yeah, they didn't have the normalization on it.
Yeah, but I mean that's
whatever. It's just 1 over 2 pi. Yeah.
Yeah.
Okay. Y equals xh. Right, and that came from this. Y equals xh.
Mm-hmm.
Uh-huh. Okay, so let's see. Uh-huh. And then yeah, okay, I guess we could do the integrals separately, which we know the h integral, which is what we did here, is this. And then hw squared is always less than absolute value of h squared.
Oh, and that's just by that the hint they gave us.
Yeah. I think I see that.
Yeah.
Oh, because H1, this was this wasn't hit. This was the third definition thing.
Yes. Yeah.
Okay. So big H omega was equal to this. This is just the definition of the Fourier transform. And then when you Fourier transform this, interesting. Why the fuck do you just get rid of the e to the I omega t?
I think they're just saying. I think what they're just saying.
Oh, they're
is,
just saying
like,
it's less than.
the
It's less
value
than
of
this.
the integral is less than that.
Oh,
and they're just saying
okay.
that's equal to
Yes.
whatever this absolute value h1 is.
I see.
Because we don't need to know what that value is. We
Right,
just need to know
right.
whether or not it's finite.
I guess this goes away with absolute value. Because this makes it like a conjugate. This makes it the e to the I omega t.
Yeah, that just
times
means we're just
e to the
talking about
negative I
magnitude.
omega t, and then you square root it. Yeah, okay. So that goes away. I see. And yeah, okay. And so this thing is less than this thing, but this thing is finite. So that tells me that the h omega integral that I do is finite. Okay. And I can pull that out then.
Yeah.
And then here's x omega. But then we say that
Which
the
is
energy in x omega is also finite.
That's Raleigh's. Yeah, and that's Raleigh's energy theorem. So then that energy is finite.
I see. Yeah. Because then when you do it for x omega, it's also equal to x of t dt. And therefore this is equal to this, which is equal to this. But okay. Sure. Alright, that makes sense to me. Does that make sense to you?
Yeah, that makes sense to me. I mean,
Okay.
the proposition itself, it makes sense. Like,
It's all
if
the
one has
it's just the
finite
notation.
energy, the
It's just
other
all the
has finite
notation.
energy, and then,
Yeah, the notation's
yeah,
just
it's
annoying. I get it.
the-
Okay. This was like extra information. I don't think we really needed this. Right?
I don't think so. I think it's just there to remind you of like convolutions and transforms.
Yeah. Right, because you had to then recognize that when you do the integral, I guess you can do these as two separate integrals, and then that,
Yeah, I think so.
and then that we already know what that one is. Okay, cool.
Yeah.
All right,
Well, the book likes to hold your hand a lot as you go through
my
questions,
hand was
which-
fucking dragged.
That's dope.
yeah, that's a better way to put it.
This thing was just dragged. I was just like, okay, I believe you, dog.
Yeah.
Okay, cool. Oh man, Fourier transforms are cool. They do get used a lot in
Yeah, they're pretty
Physics.
helpful.
They're very helpful. So yeah, understanding them is great. I use them more like experimentally in my PhD. Like I would say like I use them like practically.
I've used a lot more of the Fourier series. Like I had to write a paper last semester for PDE on some like applications of PDEs. I talked about like E&M and like signal transmission and loss and like square wave propagation and dielectric attenuation and all that. And I
Dang.
used a lot.
This is all for a double E degree?
Yeah. No, I'm a math major and a computer science major. I was just taking PDE.
Oh,
The
just for the
thing
fucking
was,
fun
part
of
of
it.
it too was, yeah, it was part of it was like a bit of a cocky confidence booster.
Yeah.
When I walked in and when the paper was due, it was the last day, and I walked in, and this was my first semester of my sophomore year, last semester, right? I'm only a
Yeah.
sophomore. I was in a class filled with a bunch of seniors taking PDEs. They're struggling,
Yeah.
like they're studying all the time. I'm walking in, I'm like partying every weekend, not really studying, really enjoying my life. And I walk in, and my paper was 32 pages long. I couldn't staple it together. I had to bring in a binder instead to bring it. And we're handing the teacher the papers because he wanted them printed out on paper. And the chick next to me looks over as I'm handing him a literal bind.
Like a thesis.
She's like, is that your project? Is that your paper? And I was like, yeah, it's 32 pages. She's like, what? Like the page requirement was 10. And I was like, yeah, I couldn't write it in that short of a paper.
It wouldn't fit in the margin.
Barely through. Yeah, exactly. I was like, I was barely through like my derivations at page 10.
Wow.
Because I started with like Faraday's law, Ampere's law, Gauss's law, and Gauss's law of magnetism, and then I derived all of the differential forms and all of the integral forms of Maxwell's equations to the Laplace equation to the electromagnetic wave equations, and then the like signal losses and attenuation.
What did you get on the paper?
I honestly don't know. The teacher didn't like ever submit it, but I imagine I did pretty good on it because
32 pages is a lot.
I don't know. I don't think he did, to be honest, because like the day before I was asking him about like formatting questions, how he wants like the sources and stuff formatted. And it was like, yeah, I'm almost done. I just need to add a couple more paragraphs, do like my conclusion and stuff. But yeah, I'm almost done. I'm at 32 pages, and he's like, no. Looks at me like just like shocked.
You're fucking crazy. Get out of here.
The first day when he had introduced the paper, he was like, so the requirement is at least 10 pages, but if you want to do more, you can. I enjoy reading. And then the look on his face when I told him it was 32 was that he doesn't enjoy reading.
Yeah.
But I
You done messed up, Aaron!
I think he was like, yeah, give the kid an A and just get out of here.
Yeah, I don't even know. I ended up getting a B in the class as a whole, but that was pretty good considering that it was 80-20 for the class grade-wise. So 80% of the class was all just like your tests. And the first test, I think I got like a 75 or an 80. And then it kind of like, I think I got a 70 on the second one. And then I forget what I got on the third one. But it was enough that I had to get damn near 100 on the final and the project to get an A or a B, and I ended up getting a B. So I was sufficiently happy
as a sophomore.
My lack of effort in class. Yeah, I mean, I did not study at all. I remember the first midterm I took was right after my car accident, so I had spent the entire weekend like basically just crippled in bed, not studying at all. And then I was like, well, shit. It's at least fresh on my mind, and I know if I push off the test later, I'm not gonna study. So I had taken it. I had a doctor's note. I wasn't even supposed to be in class that day, but I was like, whatever, I'll suffer through it and take the test.
It's better than getting a 0. Or like, yeah.
Well, I could. Even when I had mentioned it to him one day, just in like conversation, he was like, yeah, you could have just like told me and I wouldn't let you taken it later. And I was like, yeah, if I had taken it later, I wouldn't have done it.
Yeah. You know yourself.
Yes,
okay,
I
cool.
do. That's the best thing to know.
That's the best. Know yourself. You're great.
Bing, bing, bang.
What's up? Let me help out Tomboy before he falls asleep. What's up, Tomboy? Does your mic work, Tom?
Emergency.
Yeah? You can hear me? Yeah?
Yeah, I can hear you.
Perfect. Okay, here. I'm gonna let you just skip the line. I'll do your question because you've been waiting for a bit. Cool. All right, let's see. Find the absolute maximum and minimum of the function. Cool. This is like a polynomial, right? Over the interval. Round your answer. Blah blah blah. Use a comma. Cool. All right. So, do you know how to start this one? Or have an idea of like what we do?
No.
Okay, I'm gonna teach you.
I don't. I don't feel like she explains stuff well. So.
That happens. It happens. So what you always want to do, if you're ever asked to find mins and maxes, is you want to first like take derivatives, because derivatives are where we find maxes and mins and maxes and all sorts of things. Okay. So this is our function. Luckily, it's a nice just like polynomial. There's just a bunch of terms with exponents. And so if we want to figure out what the derivative of this is, do you know how to take the derivative of this?
I think it would be 5 over 2 times 2 over 5.
Perfect.
And then 5 over 2 minus 2 over 2, which would be 3 over 2.
Good. Nice. Yeah, x to the 3 over 2. And so, yeah, this one, what is that? Minus 4 over 3, 3 over 2, then x to the 1 over 2. And then what was this one? X squared? Yeah. And then this is plus 2 times 1/2 x, and then that goes away. Nice. Okay. So this cancels, which is nice. 5/2 and 2/5.
Yeah.
So you just have x to the 3/2 minus 2x to the 1/2 plus x. Okay, that's f prime of x. Yeah. All right. The next thing, so this is like step 1 is usually like take derivative. Cool. Step 2 is then set the derivative equal to 0, because that's going to be what are called your critical points. And critical points are places that maxes and mins are likely to occur. The other place they can occur in terms of like being an absolute max or min are the endpoints, and we'll check those at the end. So I'm going to say, okay, f prime of x, which was my derivative, is now equal to 0. And this equals x to the 3rd minus 2x to the 1/2 plus x. Okay. And now we want to see where this is equal to 0. Okay, cool. Well, one. Oh, and sorry, where'd the on the 3?
You forgot the half on the 3. Yeah.
Yes, I did. I fucked up. Yeah, you're right. I forgot that.
Yeah.
Okay. So this is one of these things like by inspection. I see if x equals 0, right? This whole thing just equals 0, right? This is kind of weird. This is a weird thing to try to like set equal to 0. Usually it would be like a nice quadratic or something. But they
I think you can get a decent if you multiply everything by x squared, right?
Yeah,
You get
yeah.
You'll get x cubed minus 2x
Plus x to the
plus
3rd.
x cubed.
Plus x cubed. Yeah, okay. Let's do that.
Yeah, so if you
I like
multiply
that
by
idea.
x squared, then that removes
Yeah.
all the fractions.
I usually don't like, I don't like the fractional exponents. These like suck.
Bruh.
So one way to get rid of them is to remember if you have like x to the a times x to the b, this is x to the a plus b, I guess, right? Yeah.
Oh yeah, so you. Oh yeah.
So you want to multiply by x to the 1/2. Yeah. The substitution, I think, is what you want to do. I don't think you want to multiply. Yeah. Here's what you do.
Yeah, I was thinking something.
Yeah, you're close. All right. Let's let a equal x to the 1/2. I think that's what we want to do. Jeff says that not
and
that
this
either.
is no, this is okay. This is a polynomial. This is a cubic. Sorry, in
Cubic. Yeah.
Yeah, and x to the half. If you let a equal x
So
to the 1/2, you
a
get
squared is equal to
a
x, right? And then a cubed is
Yeah.
equal to x to the 3/2. Bingo, bango.
Yeah.
Good job, gents. All right. Does that make
Oh,
sense?
Yeah.
Tomboy?
Explain it one more time.
Yeah. Okay. So this is weird. I don't like seeing x with like fractional exponents because it's kind of hard to see what the solution is. So what we're doing is noticing that x to the 3/2 is the same thing as x to the 1/2 to the 3rd.
I think
This is-
another formula might be used, either product rule or
Not a product rule.
another
Okay.
formula.
I
No,
think what you
I'm not
want to do,
sure.
you want to write this. So watch here. I'll show you. So, okay, so x to the 3/2. That's the same thing as if you divide by x, it's quadratic. Is it? Divide by x? No, it's not. Jeff, no, I don't think it is. Okay. This is x to the 1/2 to the third. And then x.
Oh, I see it. Jeff's saying it's a quadratic in x to the 1/2, but either way, we're gonna have to solve it as x to the 1/2, no matter what we get into.
Exactly. Yeah. There we go. So x by itself is the same thing as x to the 1, and that's the same thing as x to the 1/2 to the 2, and then of course x to the 1/2 is just equal to x to the 1/2. So what we're doing here is we're saying, okay, let's pretend that x to the 1/2 is a. So this is equal to a to the third. This is equal to a squared. And then this is just equal to a. Just regular a. And so now this whole thing here can get rewritten as 0 is equal to a to the third minus 2a plus a squared. Okay. Do you see how we turned this into this?
Yeah. Yeah.
Okay, great. Okay. Because then from this, notice how like I have an a and everything? I can pull an a out. I can factor an a out. So that's going to be a times, and then this is going to become a squared. I'm going to reorder this, and then this is plus a, and then minus 2. Okay?
And that accounts for our 0 case.
That accounts for a 0, which is nice, yeah. Okay. So now solving this is easy, or easier, because the values of a that cause this whole thing to be equal to 0 is either this equals 0. You say, okay, a equals 0 is one of those places. Or this is equal to 0. And this factors to a minus 1. And what is it? Let me think. A minus 1. A plus 2,
A plus
right?
2.
Exactly, yeah.
Yeah.
A plus 2.
Good. Very good. Very good. Very good. So then that tells me a is equal to 1 or a is equal to negative 2. Yeah? Because if a equals 1, that would be 0. If a equals negative 2, that would be 0. Okay. So here are 3 values of a. But we got to go back and remember.
You done messed up, AA Ron!
The negative 2 doesn't work. Because a was equal to x to the 1/2. Right? Which is the same thing as like the square root of x. Or actually, it does work, actually. I take that back. No. No, it doesn't. It doesn't work. Yeah, it doesn't work, actually.
Yeah, you'd get a complex value.
Yeah, it wouldn't work. Yeah, exactly.
It would suck. Complex
suck.
and irrational.
Yes. So, all right. So for this one, 0 is equal to the square root of x. Cool. X equals 0. That's 1. We like that. If 1 is equal to the square root of x, that means as x is equal to 1. Another 1. But if negative 2 is equal to the square root of x, this is not possible. There's no way for me to take the square root of something and get negative 2. So, what we've now done,
Gotcha.
we've found our critical points. Yeah, cool. All right, so here we go. So critical points. At x equals 0 and x equals 1.
I think it is. No, I think it is, because if we're saying that a to the 1/2. Oh.
No.
Never mind. Yeah, sorry. I was thinking once you wrote square root of 2 equals, or
I know.
2 equals square root of x, I thought.
Ooh, let's just square both
it,
sides.
And you get 4. Yeah. I was thinking the wrong
You
way.
can't do it
I was
though.
thinking,
Yeah, it's
Yeah, I had to
unfortunate.
swap.
Can't do it. Okay, so x equals 0, x equals 1 are our critical points, right? The cool thing here is that like 0 is actually one of the endpoints, so that actually kills like 2 birds with 1 stone. We're not gonna have to check the 0 one, but okay. Now, once we have critical points, there's a couple ways to do this. So we could either do second derivative tests, or we could do what's called like, they create like a table, and we could check first derivatives, or you can literally just plug the points in. It depends like what your teacher wants. They said they just want the absolute max and the absolute min.
You can do.
Which one do you want? Which one do you want to do?
A second derivative.
All right, let's do the second derivative test. That's fine. Yeah, we can do second derivative
Is
test.
it? So what? Calc AB or?
Yeah, what class is this, Tomboy? Like, what is it? A college class or is it a high school class?
Calc 1.
Calc 1 at college, probably. Yeah.
Oh, okay. I know when I did it in AP, I remember they would basically ask you to evaluate the limit as it goes from left and evaluate the limit as it goes from right of the derivative.
And then
And
see
then
whether it was
the
sloping up,
signs
sloping down, and whether it does that. Yeah.
Yeah. But they
That's one way to do it.
would like specifically ask you to evaluate the limit of it.
This is also
Which was-
nice. This is nice though, doing a second derivative, because this is very easy. Sometimes the first derivative gets something kind of weird, and then taking another derivative would be like really difficult, because then you'd have to do like another bunch of like product rules or chain rules or stuff.
Yeah, especially if it was the logarithmics are the ones that get really nasty on the second derivative.
Yeah. Fnatic says, "Oh, the second derivative method doesn't work on the endpoints." Oh, it doesn't? Oh dear.
Yeah,
Well, why not?
I don't remember. I think he's right. I don't remember exactly. It's been a while since Calc 1, but generally, I think the easiest method usually I feel like is the tables.
Yeah.
Just because you only really have to evaluate either the point on the left or the right. Because once you get to that 0, it's going to change.
Yeah. Let's see this. I'll do both. So, doing the second derivative, right? You get this. And then all you have to do is plug in what the points are, right? So, f double prime of 0. Well, this is 0, this is 0. That would be equal to 1. And f double prime of 1, that would be 3/2 minus 1, which would be 1/2, and then plus 1, which is 3/2 again. Okay. So in this case, these are both positive. And so what does it mean when the second derivative is positive for whether this is like a max or a min? Has to count with the concavity, right?
Yeah.
So second derivative positive usually means it looks something like this, and so this would be a minimum. If the second derivative is negative, then usually you have something like this called like sad face, and that would give you a max. But they want the absolute max and min. So I think actually the easiest way to do this, you don't even have to create the table. It's just plug in the points x and just see what the y values are. So that's what I would do here. I would be like, okay, cool. Here, I'm just going to plug in like x points and y points. So I know, so 0 and 1 were critical points. And then also we need to check the endpoints. So the other thing we got to check is 0 and 4, but we're already going to check 0. So then here, these are the possible locations of an absolute max or min. It's either at the critical points or it's at the endpoints. And then let's remember what the original function was.
I think a equals -2 was included in that. I think a equals -2 is also valid.
-2 also isn't on the.
Well, no,
it
but where we say square root of x equals -2, right? So we're saying that a equals -2 and x equals 1/2, right? So to
X
solve
equals
that
1/2?
equation for x itself, x becomes 4. because you square both sides. So you
But-
get
but-
negative
but
2
this-
squared.
But the square root of 4 isn't negative 2. That's the issue.
Square root of 4 is, though. Square root of 4 is plus or minus 2. Or
No, I think it's just the positive one, right? You could also look.
no. In math, we consider both the positive and the negative, because
let's
negative
see.
2 times negative 2 is 4.
Let's see if we put 4 here, for instance, right? We can also just plug it in, right?
Wouldn't that be the case if 4 was negative though? Because positive 4 is just 2.
Because generally, that's why, like, when you talk about like your quadratic formula, you have the plus or minus.
Correct.
Like the square root describes a positive and a negative value.
Well,
So
the ultimate of like whether it works or not is like just try plugging it back into what the derivative is, right?
Yeah, sure.
So if we do 4 to the third, which is 64, and then square root that, you get 8, right? And then that's minus 2 square root of 4, which is like times 2, and then plus 4. So is 8 minus 4 plus 4 equal to 0? I don't think it is. Right?
No, it's gonna be equal to 8 because of 4 and negative 4 would cancel.
Yes. Yes, it would just be equal to 8. Yeah. And if you did the negative one, for instance, so that would be negative 64. But then you're doing the square root of negative 64, so this like kind of breaks, right? Do you see how like
that's why I don't like when they put square root, because it gets weird if you then like if you're because
it already breaks.
you can
breaks like off the bat.
consider both, but yeah, I mean it just gets weird because generally I feel like we consider the positive and the negative solutions.
Correct. Yeah.
Except for when I do it, I usually just say whatever. I'm focusing on the positive domain or the
Focus on yourself,
domain.
kid.
But it gets weird. Yeah, it gets weird.
Okay. So we agree, right? These are 2 endpoints. This is a critical point. And all we're going to do to find absolute maxes or mins, you're just going to plug this into your original function and see what you get. So if you plug in 0, this goes away, this goes away, this goes away. You just get negative 5. And then if you plug in 1, you're going to get 2/5 minus 4/3 plus 1/2 minus 5. Okay. That is ugly as anything to deal with fraction-wise. Oh, man. What's the common factor there? 15? 30? Yeah, I think 30 is. Oh, man.
Yeah, 30.
30.
30 is a good one.
Yeah, so that's 12 over 30 minus 40 over 30 plus 15 over 30 minus 150 over 30. What is your teacher doing? Why? Okay. 12 minus 40 is negative 28. Plus 15 is negative 13. Minus 163 over 30, I think. Someone check my math if I'm okay there. I think I am. Negative 28 plus 15 is, negative 13. Okay. And then plugging it in for 4. I need a calculator. I don't want to do... Oh, well... Yeah, it's a bunch of factors of... It's a bunch of factors of 2, but multiples of 2. I'm just gonna plug the calculator in. All right.
I figure you could check if all the first derivatives are all positive, then it never changes and it's just constantly increasing. So 4 would be the...
Yeah. So, yeah. I see. All right. Times 2 over 5. Equals that. Minus 4 over 3 times 2 to the third. Okay, goes that. Plus... plus 8? Right? Okay, minus 5. Nice. Oh, that's what Mathematic Fanatic got. Nice. 5.1333. Okay, cool. Nice. Good job, Crazy. All right, so then negative 163 divided by 30. What was that? And that is negative 5.433. This is very interesting, actually. Yeah, I'm not sure the derivative is always positive then, right? Because look, this goes from negative 5 to negative 5.433 back up to 5.133. Yeah. Okay. All right. So the absolute min.
Well, I mean, because I'm looking at it on Desmos, and it's just constantly increased. Oh no, I forgot the negatives.
No.
Yeah, I forgot the negatives.
You gotta get in the hospital now.
All right. I think we got this one. All right. The max is at 4. X equals 4. The minimum is at x equals 1. This happened to be 5.133. Or no, sorry. This is negative 5.433. No. Sorry. No. Max is at... I'm on such struggle street today. 5.133, and then the minimum is negative 5.433. There we go. Okay, cool. That's it. Did we explain that slightly better than your teacher there, Tomboy? Yeah. There was a lot of like I was tripping over myself so much. Dude. Anyways, in general, how you do these questions, if they're just asking for what's the max, what's the min, and you have your function, the quickest way just to do it is take the derivative, set it equal to 0, find your critical points, and then just manually test what the y value is for each one of those critical points and for any of the endpoints. And then from those y values, pick out which one's the greatest, that's the max. Pick out which one's the least, that's the min, and then you're done. Yeah.
Okay. Thank you so much.
Okay, you're very welcome. I'll put this in the Discord. I'll tag you in it, and so you can have the screenshot of it and everything. But
Good job.
I hope that helps. And feel free to come by other times. We'll help you out more. Cool.
Thank you.
All right, you're welcome. Nice. Oh, equity accidentally got rid of yours. Ugh. This is what I get for raving over the weekend. My brain cells are like done. Alright, so wait, Tomboys we just did. Mark that one is done. Okay. Okay. Template. What the hell? Template. Okay. Dun, 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 dun. Okay, there we go. Yes. And there, I'll tag you in it so you can see it. Cool. I should give Lonely Me his 2K me first. Sorry. Okay, yeah. Lonely Me, we'll do yours. Yeah, sorry. I didn't see that on the redemption. I should put like a sound thing with that, maybe. Alright, let's see. Where was yours, Lonely? Dun, dun. It appears they left, though. Oh, okay. What's up, Narosky? You typing? I'm going to sleep. I'll just copy the answers tomorrow. Okay. Dude,
once I saw the
dude,
phrase,
I did it. No, equity. I'll do yours next. Okay. I did the fucking Trump hands.
Boy, not that tactile, trust me. You're
God
not that
damn
guy.
it! Oh, I did it, dude. To a T, man. Oh my fucking god. Equity, don't worry. No, I'll do yours next, because you probably had the best chance. Alright, let me do Lonely Me's. And then they'll see the recording of this. Yeah. And Equity, I'll do yours after this. And then we'll go back to playing gambling of things with questions. Noteworthy. X naught is a global maximum if x naught is less than f of x for all x. Wait. Is if f of x naught is less than f... Wait, that's if it's a minimum, no?
Yeah. Okay.
Sorry, minimum.
Oh shit, not good.
It's okay, dude. It's fucking Monday, man. We're all making...
That's what I'm saying.
It's such a Monday moment, dude. I submitted 67 minutes ago. Is that what it says? 67? All right, here. Let me do Lonely Me's real quick. I need some sanity in my life right now. Otherwise, I'm gonna start doing this more. Okay. An airplane takes off from a flat runway with a vector of 30, 40, 50. Determine the angle of elevation the plane makes with the runway as it takes off. Wow.
Oh yeah.
Oh man. Okay. But where's the fucking runway though? Is the runway in the XY plane at z equals 0? We assume, but like which direction is the runway as well, right? I think we have to make a couple of assumptions here, right? Like, what direction is the... Yeah, I understand it's on the ground, but okay. All right. Plane of runway. I'm assuming we're just saying like z is equal to 0, right? You have the velocity vector of the plane. Okay. Otherwise, the plane wouldn't be on the runway. That's true.
Good job.
Okay, so the runway vector is equal to 30, 40, 0, yeah? We cool with that? It's a more interesting question if we assume the runway is along the x-axis, yeah. There's a couple things. I'm assuming this is the vector along the ground. Okay, cool. So then if I want the angle between these two, can I just dot product this? Angle between vectors? Yeah, right? So A vector dot B vector is equal to magnitude A, magnitude B, cosine theta? Yeah. Okay, so 30, 40, 50 dotted with 30, 40, 0. That's equal to 30 squared plus 40 squared, which we know is technically equal to 50 squared, right? Because this is a... yeah. Which... not good. What's wrong, Fnatic? Okay, so I know this is equal to 50 squared. Cool. And then, so magnitude of angle A is the square root of 30 squared plus 40 squared plus 50 squared. Magnitude of angle B, or vector B, is just square root of 30 squared plus 40 squared. Which, cool, that's just equal to 50. So, so 50 squared is equal to 30 squared plus 40 squared plus 50 squared times 50 cosine theta, right? I think we're good here. One of the 50s cancels. Right? Okay. Alright, so we do 50 divided by the square root of 30 squared plus 40 squared plus 50 squared. Ooh, 0.707. That's kind of cool. Yeah, wait, that's something nice, isn't that? Yeah, square root of 2 over 2. So it's 45 degrees? Yeah, 45 degrees. Okay, cool. Nice. Cool. Nice. We did it. It's a 50-50-50 square root of 2 right triangle. Okay. That's one way to do it. Nice. That's a cool one. That was number 3. Nice. Okay. It's always nice. I'm always hating on the TID4, but it does have a nice square root notation, yeah? Well, so this is actually an advanced thing. It's called math print. How it does the square root notation like that. That actually came later in the 2000s. It used to be, I think if you go down to classic, this is usually what it actually is for square root. So this is how they write square root. This would be like square root of like x squared. Actually, if you go up, yeah. So that's what it looks like. But then you can turn math print on. This is I think this came in the later like early thousands, and now it looks really pretty. Yeah, it was a cool improvement. Okay. All right, equity. Let me do yours because I accidentally hit post on yours.
Nice.
And this also is related to like concave up and down stuff, curve fitting. What's up, Toast? Thanks for the follow.
Oh, yeah.
All right, let's see what we got. Inline notation. Is that what they call it? What's up? What's up, Obi?
Oh, yeah.
Shout out to Obi. Okay. All right, the graph H is shown along with the 4 points A, B, C, D. Sketch a line tangent to the graph H at the 4 points. That's fun. Okay, so whatever. That looks kind of tangent-ish. It's pretty tangent. Let's use different colors for all these. Oh, no. This one's flat for sure. And then this one looks something like this probably. Okay, there we go. Made some pretty graphs. Order the rate of changes from least to greatest. Ooh. Can the line be perpendicular? No. No. Because then it would have an infinite slope. And that's not possible. Or it's not, like, well-defined. Order the rate of changes from greatest? Oh, from least to greatest. That's a good question. I think D is lower than A. So I think D is the most negative. A is, like, not as negative. B, and then C is equal to 0. And then B is the only one that's positive in terms of slope. For each of the following statements about the graph H, circle the correct answer and the correct reasoning. Okay. From point A to B, the rate of change of H is... Okay, let's see what the rate of change is. So the rate of change is the slope of the tangent line. So that's going from negative to positive. So going from negative to positive is increasing. So rate of change is technically increasing. And because the graph is, well, A to B is concave up. Smiley face. Yeah, concave up. From B to C, so it's going from a positive slope to a 0 slope. So that's technically decreasing for rate of change. And that's also, in terms of concavity, that's going to be a negative. What's up, Sam? Good to see you, dude. Okay. So, oh, wait. Wait. Sorry, I read this wrong. Sorry. From point B to C, the rate of change... The rate of change is positive, technically. It's not increasing. If anything, it's decreasing. But the value of the graph from B to C, that is increasing. Yes. And that's because the slope is always positive. When the slope is positive, the graph has to always be increasing. The slope goes from being, like, positive to, like, not so positive to 0. But technically, it's never negative. So it's never decreasing. From point C to D, the rate of change... Well, that's decreasing. It goes from 0 to negative. And that's because the graph is concave down. Yeah. Isn't perpendicular slope the negative reciprocal? Yes. What's up, FaZe? Submit your question to the queue. FaZe, that's how we do questions here on the live stream. Yeah. Wouldn't C be the least rate of change? Yes. C has... Well, no. Least is tricky. Least means most negative, technically. Right? This is like 0 rate of change, right? But this is negative rate of change. So this is like technically less to more. Does that make sense, Equity? I understand that it's not changing, but the rate of change is technically 0 when the slope is 0, or the instantaneous rate of change. But it's not the least. The least is the most negative. Right, -3 to 5. This is like least to greatest. If they want the magnitude of the rate of change, then yes, C is the lowest magnitude. But usually they want the positive or negative. Least net change might change that. Yeah, okay, maybe least net change. Yeah. But okay. Does that make sense, Equity? Yeah. Yes, cool. All right, awesome, great.
Nice.
Okay, let's go see what's in the queue. And let's go gambling. Let me give you a point equity, by the way. Sorry, my bad. There you go. Gladiator, your time has come. Thank you for waiting 82 minutes. All right, cool. Here we go. Wow, yeah, this is an example of where like doing derivatives sucks.
Huh?
No. Yeah, well, it doesn't look too bad, but like, man, I hate doing derivatives. This is the quotient rule, but like many times, right? Isn't it the quotient rule? I mean, you could do a product rule, the chain rule, but it is tedious. Yes, very tedious. Bigly tedious. Quotient chain. Okay. All right, Gladiator. So what you learn, if f of x is equal to like, let's say a over b. Oh, I see. Right. So then this is equal to ABBA. Right, it's equal to a prime b minus b prime a all over b squared. FaZe, did you submit your question? Okay. So, in this case, a is equal to 3x. B is equal to, I'm going to write this as an exponent. So I'm going to say 4x squared minus 3 to the 1/2. Reason why is because this is a little bit easier to then calculate a prime, b prime. So a prime is just equal to 3. Can't we make it into a polynomial and then do f to the n x equals n factorial for higher derivatives? No. This can't really turn into a polynomial. I don't think so. Because even if you try to like rationalize the denominator here, predicts Dr. Gold will give up this question in 24 minutes. Why would I give up in 24 minutes? I think it's just a tedious question is all it is. Okay, with negative exponents. So, if you were to turn this into 3x... I probably will, honestly. 4x squared minus 3 to the negative 1/2 is what you're saying if we did it this way. This isn't a polynomial, is the issue. I guess you could try to, I don't know, like bring this inside, but like, oh man, just like, no. What, you're gonna bring in 9x squared in? Like 1 over 9x squared, I guess? No, sorry. Yeah, right? Wouldn't this become 4x squared over 9x squared minus 3 over 9x squared all to the negative 1/2. So what would that be? 4/9 minus 1/3x squared to the negative 1/2. The issue is that, so once you take your first derivative here, you're going to end up getting one of these terms out front, and then it's going to keep becoming more product rules. So watch, like, f prime of x would then be equal to negative 1/2. It would be this 4/9 minus 1/3x squared to the negative 3/2. But then I have to take the derivative of what's inside. And so that becomes... it's negative 1/3 times negative 2. And then it's 1/x to the 3rd. Because, yeah, the derivative of 1/x squared is... So that's x to the minus 2, so that's negative 2x to the minus 3, which is then this. Yeah, this is a mess, though. Because then, this times this then becomes a product rule for doing the second derivative. Which is going to pull out another, like, 2 terms. You're going to, like, double terms. Yeah. For this one, right, 1/2... 4x squared minus 3. I'll just show you why this gets really messy. I don't think I'm actually going to do it. I think Jeff is right.
You done messed up,
I'm not going to do it because it is a mess. You created this problem, did you, right? Like, this isn't a question from a textbook. No one in their right mind would ask this. No one of sane thought would want to do this to somebody. This is a teacher's worksheet? No, this is terrible. I mean, look, just from calculating the first derivative. Right? So a prime was just 3. But then times b, so then times 4x squared minus 3 to the 1/2. B and C should be left for the student. Dude, B and C is left for, like, my grave, dog. I would just refuse. What's up, Pineapple? What's your question? And then this would be 16x squared. 4x squared minus 3 to the minus 1. What if there's a parentheses 14 on out parentheses 1/4 outside of the quotient rule for his example? Sorry, what's the parentheses 14 mean? Pineapple? Yeah, it's fine to do higher order derivatives, just like higher order derivatives of fractions start breaking really quickly. Oh. The parenthesis to the 14th? Where do I have something to the 14th? What looks like I have to the 14th? This is to the 1/2. What looks like 14?
He said what ifs. He said, but what if it's overall 14?
I don't know what that means. What if it's all over 14? Sorry, what?
Pineapple, have you learned the chain rule yet?
Or I think, he's saying this maybe. Are you saying all of this to the 14th and then take the derivative? Yes. Okay. I was just wondering why you picked 14.
Yeah, I see. Yeah.
Yeah, that is a chain rule. Yeah. Okay. So pineapple's a little like side quest here. Yeah. Okay. Yes. If you had 3x over 4x squared minus 3, right, which is to the 1/2, all to the 14th, the derivative of this would be 14 times 3x over 4x squared minus 3, all to the 1/2, to the 13th, and then times the derivative of what was inside. So times the derivative of this. And the derivative of this is like literally what all this fucking hot garbage is.
Out of curiosity, is this like what you write on, like I guess the app that you're writing on? Is that like someone else's app, or did you like make?
Oh
that?
no, I didn't make it. It's called Group World. It's just like kind of a whiteboard thing.
Oh, okay. I'd have to check it out because OneNote's been pissing me off. I'm not gonna lie.
Oh yeah.
I was curious because the copying in OneNote sucks, and then when you export it like breaks up lines and stuff. So I was curious.
Garbage. Yeah, I'll send you a link for it.
Perfect. Appreciate that.
Yes, and then you would use the quotient rule. Exactly, pineapple. Yeah, this whole thing would be the quotient rule. Yeah. Okay, just for funsies here, because all right, we did the first derivative. Yay. Good job. Doing the next derivative is an absolute nightmare. You don't want to do that at all. It's just a huge pile of shit, dude. Like, I'll show you. Like, this is a great.
Just one big pile of shit.
It's a great thing for AI to just choke on, because.
Run that back. Did I see the fourth derivative?
Yes, he wants the teacher wants the fourth derivative.
Dude, report your teacher to the district, bro, or something. At this point, this is child abuse.
That's child abuse, dude. Yeah, the fourth derivative.
Even in physics, we don't use the fourth derivative. We're like, here we got acceleration, we got velocity, we got position.
Then we got jerk.
Don't worry about anything past that.
Don't worry about acceleration changing. Here, both of the AIs are just like upset at this. Yeah, I don't think you can do this easily. Yeah, look.
I figure Wolfram could probably do it.
So there you go. So that's the first derivative. Sure. Second derivative becomes that. Oh, I guess it's not too bad. And then this is the fourth derivative. It's just ugly.
That's pretty bad.
It's pretty bad, man.
That's like...
This is why Leibniz was better than Newton. I guess the nice thing is at least the 12x squared cancels up here. Do you see that? I should kind of see. I'm curious how's that working, by the way? Sorry, what? Wait, did AI even do this correctly? Sorry. 3x over 4x squared.
Probably not.
Probably not, right? Yeah, I don't think it's that simple.
Yeah, like when I had asked it that the calculus of variations question that I had that was saying that they put a typo in, it took me like 6 hours like back and forth with AI because it just kept doing what it should have asked or what it should have said in the book.
Yeah.
And it didn't. It would just like do it without the R prime, and it would be like, it just simplifies. This is just the
dog.
answer.
We're there, dude.
And I'd be like, how does it get there? And it'd be like, we just got there. I feel like AI likes to jump steps and simplify. It's like when a book tells you like, prove that this is the answer, and you get really close, and you're like, well, I don't know what to do from here.
It's an exercise for the
And then
reader.
you just make it look like, yeah, it just makes it look like you did the mental math in your steps. So, and you just hope that the teacher doesn't notice.
Yeah. Or the
That's
graders.
kind of what AI does.
Graders too lazy
Yeah.
to check it.
Yeah, exactly. I feel like that's how AI normally does it.
Let's see. What do they do here? They multiply by the square. To simplify, multiply the numerator and the denominator by that. Excuse me. I think they fucked this up though. Oh, sorry. Wait, no, that's to the 1/2. So when you take the derivative, that should become to the minus 1/2. Yeah. And then isn't it b prime squared though? Substituting into the form. Dude, I think they fucked up here on the middle step. Answer sheet for the 4th derivative.
Let me check. I trust Wolfram the most. of
Yeah,
all
let's
the
put it
AIs
in the
I've used
Wolfram.
that. Like, that's my go-to because it doesn't do like all the other stuff. It's just like I don't even know what it does differently, but it does it completely differently. I feel like
Yeah.
Wolfram only sucks when you like don't know how to get to an official, like an actual equation that you need to solve. Once you have like an equation you need to get, it works great.
Mathematica does prove it to be correct. Yeah, okay. Gladiators is correct, yeah. So wait, they wanted it to the 3/2, so they're multiplying. I'm just curious how they're getting from here to the 3/2. Right, a prime b, yeah, minus b prime a. And then if we want to simplify this, what do we get? I agree this is annoying. So if I divide by
so if we bring the 4x squared minus third to the negative first up top,
yeah.
Yeah, you get 4x squared minus 3 to the 3/2, and then it's 4x squared minus 3 to the 1/2.
Okay. So, yeah. If I wanted to do that, just so I can show up so Gladiator gets it. 4x squared minus 3, I'm just going to multiply top and bottom by that, right?
Yeah.
Right. Okay, so then this will kill off this. This will combine with this to get you 4x squared minus 3 to the 3/2. And then this is to the 1 to the minus 1/2, so that's going to be to the... So that's going to... And then we have a 3x and a 4x. And then that's minus 12x squared, 4x squared minus 3 to the 1/2. And then over 16x squared.
Yeah, and then this is just me because I like practical and I'm not a masochist. I'd probably break them up into 2 fractions and say, because the 12 and the 16 are going to simplify, and the x squared and the x squared cancel. So your first term is going to kind of suck, but your second term will at least be normal.
F n x equals n factorial. I don't think we use that one. I don't think we use the n factorial one.
Yeah, I don't see where we're getting factorial from.
I don't see where factorial would come from. Yeah, I agree. You could split this. You could split this.
But, and because if you split it, since we're doing the second and the 4th, because everyone wants to do a 4th derivative with the quotient rule. At least when you solve the 4th derivative, that second term is going to be a lot easier to derive than doing, because this you'd have to do your chain or your quotient rule, and then you'd have to do your chain rule, and then your product rule, and then your chain rule again.
Yeah.
But if you split them up, You just have to do
Yeah, now this is an
product
easy.
rule.
Well, this is the only one. Well, this is a quotient rule. This is just a
Yeah.
chain rule.
Oh,
Yeah.
yeah. I guess I never really did quotient rule. I just did product rule.
Product with chain, yeah. They somehow, though, they got something nice for this. They got 9 over 4x squared minus 3 to the 3 halves. I don't know where they're getting that. So if they get that on the bottom, they must be dividing the top and the bottom by 4x squared minus 3 to the 3 halves, right? So then that would get you 3 minus 12x squared. And so, wait, if you divide... So if I multiply the top and bottom by to the 3 halves... Okay, this becomes 4x squared minus 3 squared. And then this is all over 16x squared. 4x squared minus 3 to the 3 halves. Oh, I see. This probably expands somehow.
I guess that looks prettier, but like functionally as a human being, I feel like if you're trying to get to the to the fourth derivative, I think that's just
it's easier to do it this way. Yeah.
Yeah, well, because that reduces the amount of steps you have to take. This is,
let me see, minus 24x squared plus 9 all over 16x squared 4x squared minus 3 to the 3 halves. I just want to see where that x squared, how does that x squared come away? How are they doing that, dude? What the hell?
I don't see, that's what I think that it's just
they
taking
get this
steps.
It's just faking
Like,
steps to get there.
Because I don't see any way that x squared is going to cancel like easily, unless you just know every step possible in algebra.
All right, one sec. He sent something in the
I don't
queue.
see any easy way that an algebra, or not an algebra, a calculus 1 student's going to find that.
What'd you submit, Gladiator? Let's see what this is. Whoa, what the hell? Oh, yeah.
No, I see what he's saying. I've done questions like that in my backpack's in my car outside. I don't feel like walking that far, but I have done a question like that in an integral book that I had
The
read.
nth degree of a polynomial. Oh.
Yeah, it's just saying that, right? So f of x is actually x to the n. It's just saying if whatever x to the n is your function, then the derivative of your function is going to be n factorial x.
Yeah.
So.
Right, because every time pulls down. Right, so watch. So
Yeah,
the first derivative is n x to the n minus 1, and then like the second derivative is n minus 1 x to the n minus 2, right?
Yeah, and then you just go about proving it by mathematical induction.
Uh-huh. So then the nth degree nth degree derivative is...
It would just be n factorial. If you say n minus 1, it would be n factorial x, and then if it's n, it would just be n factorial.
Yeah, something get really ugly. Ugh. But f of x can be any polynomial with x to the n as the highest term. Okay. I don't think that applies to this one, though. Or where was it? Because this isn't a polynomial. Just straight up. It's a rational function.
Yeah, pineapple is if pix does pi get canceled for f prime and f double prime?
Oh, pi x.
You see, but yeah, I don't think because once you get into pi and factorials, like then you have to pull in the gamma function and
No, pi is a constant, is what it is.
I don't. Yeah,
Right.
I don't.
If
see where pi comes
f
in
of
here.
x is equal to pi x pineapple, then f prime of x is just equal to pi, but then f double prime of x is equal to 0. Does that make sense, pineapple? Is that what you're asking about? Pineapple's typing. Yes, but when I asked ChatGPT, pi is just canceled out. I don't know what that means by pi is just canceled out.
I think pineapples was. I think ChatGPT is just wrong.
I wanted to know how it got to that really simple version of this, though. I mean, Gemini did the same thing. Makes me start to question stuff.
It's the first derivative of it?
Yeah, the
Or
first derivative, they get something really nice, dude. They just get this as the first derivative.
What's the original equation now? What are we deriving? 4x over square root of 4x squared minus 3?
Yeah, so, one sec. It was 3x over the square root of 4x squared minus 3. Get rid of the side quest. FaZe, if you got a question, put a screenshot in the queue. That's the best way to do it. I can't answer stuff in chat. Here, FaZe. Directions. There are the directions. That's how you do it. That's how you do it. Okay. Did we get at least this close? I think we did. Right, 4x squared, yes, okay, and then minus 3x and 4x, right? And that, I do have that. And then, oh, interesting. I had another, I had b prime.
What is...
Oh, it's fucking up this, for sure.
see, let me... Wolfram... yeah, Wolfram agrees. Let me check the...
Oh, I think I...
step-by-step
No.
on Wolfram.
You know, wait. Why is the bottom just 4x squared minus 3? Isn't there also a 16x squared down there? Am I crazy?
Let me send you what Wolfram does, because Wolfram does a... I'll tell anyone who's learning calc, Wolfram does a lot better than ChatGPT with these steps.
Yeah, for sure. To simplify, let's check to see what she did in the queue. Let me go see.
And then... yeah. There's the rest of the steps.
Oh, you know where I'm fucking up? Oh, I see. Yeah, I put b prime squared, not just b squared. Wow.
Oh, yeah.
Yeah, I just said, just show.
Oh my god. I'm sorry. I'm absolutely retarded today. Okay. Yes, it's that squared, so that's just 4x squared minus 3. Okay. Now I see why they multiply by... Yeah, okay, wait. I think I see why this works. No, your teacher was right. I was dumb. Yeah, if you multiply now by 4x squared minus 3 to the 1/2. 4x squared minus 3 to the 1/2. Now this and this. My live's being flagged for hate speech and hateful behavior. I'm hateful towards myself, TikTok, right now. It's okay. Alright, 4x squared minus 3. And then this and this becomes... Yeah. Wait. Oh, that just becomes 4x. Wait. Yes. 4x times 3x, so that's 12x squared. And then that's over 4x squared minus 3 to the 3 halves. Okay, I think I see what happens. And then look at this. This multiplies. You get 12x squared minus 9 minus 12x squared. All over 4x squared minus 3 to the 3 halves. This cancels. That's nice. Yes, and now you're left with negative 9. 4x squared minus 3 to the minus 3 halves. Aha. This is much easier now to take a derivative of, right?
Yeah, okay. Yeah, that is, because then that's just
super nice.
Power rule.
Yeah. Okay,
So then it's not like, your teacher's just trying to
yeah, I see.
make you die
Yeah, don't do that.
solving really bad quotient rules.
So this is now just a power rule, chain rule thing. So that multiplies by that, and you get 27 over 2. And then this is 4x squared minus 3 to the negative 5 halves times 8x times derivative of what's inside. Yeah, okay. So, not the nicest thing, though. So, 4 times 27, so that's 108. 108x. And then that's 4x squared minus 3 to the negative 5 halves. Which I think is probably what they got. Let's see. Yeah.
Yeah.
Right. Well, the chat, this screwed up here, actually, right? This should have said F double prime. It said F. Oh, it does say F double prime. Okay, cool. So then you have the product rule. Wow, for F triple prime. This is a product rule. So derivative of the first thing. So that's 108 times the second. And then plus the derivative of the second. So that's negative 5 halves. 4x squared minus 3 to the negative 7 halves. Times 108x. Yeah. Okay. And then the fourth derivative. No, it should increase crazy. It's when I click vote, the number of votes it adds. Oh, yeah. It is logarithmic. Yeah, well, logarithmic means, okay, logarithmic means the rate of change decreases. So it's like that. Yeah. Yeah, okay. And then, okay, this is the final, I think, derivative. Negative 5 halves, 108. And then that's going to be 4x squared minus 3 to the negative 7 halves times 8x. Yep. I added the 8x. You see that? Oh, the 8x for here. Yeah, you're right. Actually, I do need that. My bad. Yes, I did. Yeah. The amount of votes it adds decreases, but it's still adding votes, so it's still increasing. Okay. Isn't it 9/2? When we do this one, it'll be 9/2. Yes. Yeah, we're getting there. I'm getting there. This was just the derivative of this. This is 864x squared. Yeah. Okay. But now you have to do this as like a product rule. Right. This split out as a product rule. Yeah. Okay. This becomes -5/2, -7/2, 4x squared minus 3 to the -9/2, 8x, 864x squared, and then plus 2 864 times x, and then -5/2, 4x squared minus 3 to the -7/2. Yeah. There you go. Okay, cool. That's technically it. You can go through and simplify it. I'm not going to do it.
Huh?
You done messed up, Aaron.
But that's how you would do it, Gladiator. Interesting, it was only really a quotient rule for the first derivative. That's really, really fascinating how that happened.
Well done.
But then it was product rules and power rules. Okay. Still annoying. It's annoying of your teacher to do that to you. No, it's okay. I wanted to prove Jeff wrong.
Bruh. You done messed up, Aaron.
I had to prove Jeff wrong. Alright, let's mark that one as done. So many derivatives today. Indeed. Okay. I got 20 minutes left. Let's see what we got. So, let me make sure that one wasn't an actual question. That was not an actual question. So, let me delete the last two so they're not in on that. So, 8 we can delete. And then we can delete 8 again. Or 6. Yeah, 6 we can delete. Okay, cool. And I did lonelies. Did I do lonelies? I did. Okay, oh, so I can delete 3s. Okay, there we go. Oh, no. I deleted lucky cats. Damn it. Man. Delete 2. Alright, sorry, lucky cat. I have to do yours next then, sorry. I got rid of it. Fuck, which one was yours, lucky cat? Sorry. Here you go, lucky cat. It's because the ordering on the queue is not the same as the ordering on the thing. Okay. Alright. Math takes so much time. It does. Alright. 2 lines pass through the point 0, minus 24 and are tangent to the curve there. You got a test tomorrow? Okay, let's help you out.
Bing bang.
Okay, our tangent to the curve. Determine the points where the tangents touch the curve. Okay. If they're tangent to the curve, then that means their slope has to be equal to the derivative. The derivative of the function, right? So slope of tangent line. equals f prime of x. So, and then f prime of x is equal to 4x. Okay. And they both pass through that point. Fascinating. It's a parabola, so we can touch it in 2 points, yeah. Alright, so 2x squared, I just want to kind of like see what this looks like. 2x squared plus 8 looks something like this. And then, oh, I see. And then there's a point down here. 0, negative 24. I see. And we're saying that like this happens, basically. Yeah, drawing a picture really helps me sometimes. Okay. So something like that and like that. Yes, there is symmetry, actually. Fascinating. Right? Do you see how 2x squared plus 8 is symmetric around here? And also this point that they're passing through is right through the axis of symmetry as well. So whatever I find for here, the other point is going to just be on the other side. So if this is like x equals whatever 3, the other one's going to be x equals negative 3. Okay. Okay. This point is at x comma f of x. And so I need the slope of this. So that's f of x. So y2 minus y1. So f of x minus negative 24. So plus 24. Over x minus 0. That needs to be equal to f prime of x. Does that make sense? I'm finding, so the slope between the point of intersection with the curve and 0 comma minus 24 is, yeah, y2 minus y1 is equal to x2 minus x1. That's equal to the slope, which is equal to this. Right, good. And f of x is from here. So we have 2x squared plus 8 plus 24 all over x is equal to 4x. Very cool. Multiply both sides by x. Now I have 2x squared plus 32 is equal to 4x squared. 32 equals 2x squared. X squared equals 16. X equals plus or minus 4. And that's actually kind of cool. That makes sense, right? Remember I said, like, oh, if it's whatever here, the other one's going to be on the other side. So those are the points. That's the x points where it intersects. Okay. But f of x is equal to 2x squared plus 8. So if you plug in, like, f of 4 then, you get 2 times 16, so 32 plus 8 is 40. And that's the same if it's negative 4. So the points are 4 comma 40 and negative 4 comma 40.
Did you not just use your y equals mx plus b here? Right, because we know that the slope at that at that point is going to be your derivative. And since we're talking about a linear function, the slope is going to be equal the entire way, and we know the y-axis.
Yeah. Oh, I
So
see.
I think you could just use point slope form, saying, well, we know what the slope is going to be across the entire line, and we know what
And we know what the
the
y-intercept is.
y-intercept's going to be.
Yes. That works too. I see. Because this is the y-intercept. I just literally just found like, oh, if this intersects at a point here, and then this is another point, I know the slope, which is basically y equals mx plus b, right? The slope between those 2 points is this. And this is kind of point slope form, right? If one of the points is the y-intercept. I think so.
Yeah, true.
True.
I
Okay.
think it is.
I think that works too.
It says in the project that it's oh yeah, it says it's tangent.
Yeah. Does that make sense, Pineapple, how we did that? I mean, I like drawing pictures. Pictures are cool. I think that's what it is. I can explain more of the steps if it doesn't make sense. No, you're confused? Oh, well, let's not confuse you. Here. Okay, one sec. Here, just think of it like conceptually what's happening. So, let me make this the same color. So, 2 lines, right? The lines are the green things here. These are the lines. 2 lines. 2 of these lines pass through this point 0 minus 24. That's right here, okay? That's the point the lines pass through. And they're tangent to a curve, which is 2x squared plus 8. 2x squared plus 8 looks like this. It's a parabola. Or this right here is 0, 8. Right there. All right? And if these lines are tangent, right? That means the slope of these tangent lines is equal to the derivative of the curve and then here let's put some points here at x. Okay, Jeff, all good. Good to see you, dude. Right here, let me put some colors here on this. And these points, by the way, right? These points on the curve have, if they have an x coordinate x, the y coordinate for that point is going to be f of x. Because this is the same thing, right? Is y is equal to whatever you put in for x. We don't know what x is. We're trying to figure out what x is. Now, what I know is that the slope between 2 points. Here you go. Slope between 2 points is y2 minus y1 over x2 minus x1. Where this right here is what we're going to call like point 2. And this right here is what we're going to call like point 1. So if this point is at some coordinate x, and then the y coordinate would be f of x, because for every x I plug in to the curve, f of x is then what the y point is on that curve. And then point 1, where the tangent line goes through, is 0, minus 24. I can then figure out the slope of this line that connects the point on the curve to 0 minus 24. And that comes from y2 minus y1. So that's why that's this. This minus negative 24. What's up, Kari? minus x2, which is then just x, minus, and then x1 is just 0. And this is how I get f of x plus 24 over x, okay? That's the slope between the point on the curve that is tangent. Wait, the point on the curve and the 0 minus 24 points, and then the line connecting those 2 points is tangent to the curve. And if that line is tangent to the curve, that line has a slope equal to the derivative of the curve at x. This is the derivative of curve at x. Okay. Yeah, how did I get that? Okay, so I did y2 minus y1. Y1 was negative 24. Right? The lines pass through the point 0, negative 24. So minus minus becomes plus. Uh-huh. Okay. So this is the expression for the slope between these 2 points, which is the same as the slope of this line, and this line is tangent to the curve at that purple point. So whatever the derivative of the curve is at that purple point is the same as the slope of the green tangent line. Is there any trick? I don't know if there's really a trick. Is there a shortcut?
Disqualified.
I don't think there's really a short.
Well, so I would say the simplest method, since we know a point that the line needs to go through, is to just use point slope form. And even though your slope changes, you can just set that to be your derivative, right? So then you can figure out any point.
Let's see. So you're saying like point slope form?
Yeah. And in this case, that would just be your y equals mx plus b, since we're
y2 minus
intercept.
y2 minus y1 is equal to m x2 minus x1. Right. Okay. And then in this case, y2 is equal to f of x. x2 is equal to x. y1 is equal to negative 24. x1 is equal to 0. Yeah?
Yep.
Okay. Yeah. I guess this is kind of a shortcut.
And then from there, right? And because we know our m is just our derivative of f of x, right? It's just f prime of x.
Yeah.
And then you just solve the equation as is.
Okay. This is the point. This is the curve. And then the last bit of information you need here, right, is that m is equal to f prime of x. And then this is the slope of tangent line, which is also equal to derivative of function.
Yeah, because functionally, your derivative is the slope at an instant.
So yeah, that would work, because then y2 would be f of x minus y1, which is minus 24, is equal to f prime of x, and then x2 in this case is x, and then x1 is 0. So you get f of x plus 24 is equal to the derivative, which was 4x, and then this is times x. And then you gotta substitute in what f of x is. So 2x squared plus 8 plus 24 is equal to 4x squared. Sure. 32 equals 2x squared. X is equal to 4. Plus or minus 4. Yeah, the test is timed. The test time is very limited. This is the trick. I hate memorizing tricks, though, because, yes, this will work if you just memorize the process. If you always have a question that says passes through a point tangent to this curve, then...
Well, so the way I think of it is we're not memorizing the steps. We're just saying we want to find a line that's tangent to it. And we're given 2 points. So you kind of look at it and you say, okay, it's tangent to the curve. That tells me that its derivative is going to be the slope of our line.
Mm-hmm.
We're given a point. We can find the other point from the curve. How do we make a line with 2 points and a slope? Point slope form.
Yes. Yeah, okay, I see. Yeah. If you have a slope and a point, you can just do point slope.
You can adapt that to other methods.
Where...
Or other questions, I mean.
Yeah. I see. Okay. So, yeah, this is another way to do it, is this way. Visually, this makes more sense to me, but...
Yeah, I would agree.
Yeah. You can also do it with this trick. I also understand intuitively, like, why this works. Just graphically. I haven't slept since yesterday. This topic makes me 100% stressed.
Surprise, motherfucker.
Oh no, I'm sorry, Pineapple. Okay, anyways. I'm gonna mark this question as done though. But take a look at it. Rewatch the video maybe.
Well done.
Yeah, you're very welcome. Alright. I got a pineapple. Let me put the pictures in for you. Where are my downloads? I just did it. Didn't I just download both these? The hell? Oh man, no. Let's see. There we go. Okay. All right. There you go, Pineapple. I put it in the Discord for you. Oh, man. Oh, all right. Let's see. I technically have to go. Let me see if there's anything, like, easy. What did I miss out on? Oh, I do love this one, though. Man, this would have been a fun one, Iron Sights. Prove AB minus BA equals A minus B star. The adjugate? Oh, jeez. I don't know what the adjugate is. Is that the conjugate adjoint? That's crazy. Crazy Run Fan had... cool looking integral expansion. That's cool. SW. Good physics question here.
I think SW or the one right below him ain't bad. Well,
and then this is a
not bad being they seemed like they'd be fun.
And then this was just pictures of magnetic fields. Okay. These would have been fun too. I actually like these. Coefficient of friction? Yeah, fuck. Okay, yeah. I can't do any of those really quickly. So, and I do have to go. I have to go teach another student. So, don't worry. Anyone's questions here will get put into the Discord anyways. If we have time, maybe I'll do them later tonight. I don't know if I have so many jobs now that I'm working. But we do also stream tomorrow. So, don't worry. Come by tomorrow. Here is the schedule. So tomorrow will be on from 6 to 9. So an hour later. Yeah. Okay, cool. Let me end the stream. I gotta go teach. All right. How are you motivated to do all this? The kindness of my heart. That's how I'm motivated. But the kindness of my heart is tired right now. I'm barely motivated to do homework. Well, hopefully this motivates you to do your homework, because I'm motivating myself just to solve other people's homework. Yeah. Okay. Thanks for coming by. Appreciate all the help, everyone in the chat, everyone in our Discord. You guys are great. Our next stream's tomorrow, hour later, 6 p.m. Pacific, 8 p.m. Central, 9 p.m. Eastern. Struggling with calculus? Come by our live stream tomorrow, or go check out our YouTube. We have a bunch of videos on. If you go to our shorts, go to here to shorts. We got a bunch of videos on calculus stuff, volumes of revolution. Yeah, that looks like that's a chain rule question. Pineapple is what that is. That's a chain rule. Yeah, that one I might have. That's just a chain rule. Second semester senioritis kicking in. Finish strong. You guys can do it. I know you can. But yeah, if that one's a chain rule, Pineapple. Chain rule. If you look up here's our video, like how to use the chain rule in calculus. They've kind of just done the chain. They've already done the whatever, the boxing part of it. So, yeah. Go. This is how the chain rule works. I'm pretty sure you know how the chain rule works. Alright, I really gotta go. So let's go. We do love the chain rule. Let's go raid someone on Twitch. Who are we gonna go raid? Who are we following? We can go say hi to. Nice. Justin's doing some Monday night math. Go say hi to Justin. We like math. Okay. Love you guys. I'll see you tomorrow. Enjoy the rest of your Monday. Peace.
Factor out is GMM squared over L squared, which is going to leave me 1 plus, and I could write C over that whole